Hello everybody, in this video I'm going to be going over how to calculate angles using what's called inverse trigonometry. So what we have here are two right triangles. One of them, you have two legs that are 11 and 17, and the other one is your standard 3, 4, 5 triangle. So what we're going to do is we're going to learn how to actually figure out the acute angles of this right triangle. We already know that one of the angles is 90 degrees, so the question is what is the length of the other angle. So the way that we're going to do this is that we're going to, first of all, pick the first angle here, which will be, let's just call this theta. So make sure that you watch my previous video about solving right triangles first, because I'm going to be talking about sine, cosine, tangent, and you should know what that means in order to do this video. So with respect to this angle theta, 11 is going to be the opposite side because it's across from that angle, and 17 is going to be the adjacent side. So which trig function deals with opposite and adjacent? That's going to be tangent. So I'm going to write down the tangent of the angle is going to be the opposite over the adjacent, and that's 11 over 17. So now the question is, well, how do we figure out what theta is? How do we figure out what the angle is? And the way to do that is to basically say that theta is going to be the inverse tangent, written like this, tangent to the -1, of 11 over 17, and then just type this into the calculator. So let me get my calculator here. On your calculator, what you're probably going to have to do is hit second and the tangent button. It's probably something like that, but just let me know if you have trouble finding the inverse tangent. But again, you hit second tangent, you should see tangent to the -1, and you're going to type in 11 divided by 17, close parentheses, and that equals 32.9 degrees. So the theta is 32.9. Theta is equal to 32.9, all right? So that's that angle. I'm just going to go ahead and erase that theta and then write 32.9 right here. 32.9. Okay, so as you guys know, the angles in a triangle add up to 180 degrees, and one of the angles is already 90, so the two acute angles of a right triangle add up to 90. So to find the other one, I'm just going to write 90 minus the previous one, 90 minus the previous answer. There we go, that's what I meant to do. And that's going to be 57.1. So the top one is 57.1 degrees. Okay, so let's tackle the other one now. So for the other one, we're trying to figure out what the two angles are. So let's start with this angle right here, theta, and notice that you know all three sides. You know that this is a 3, 4, 5 triangle, so you can pick anything that you want to. Here, 3 is going to be the opposite side, 4 is going to be the adjacent side, and 5 is the hypotenuse. All right, 5 is the hypotenuse with respect to that angle theta. So I already used tangent, so I'm just going to use cosine here. I'm going to say that the cosine of the angle is equal to the cosine ratio, which is the adjacent over the hypotenuse. So that's 4 over 5. So there's your setup. And then just like we did the inverse tangent, we're going to do the inverse cosine. So this would be cosine to the -1 of 4/5. And we type that into the calculator and we will figure out what theta is. So let me get my calculator here. I'm going to hit second cosine of 4/5, close parentheses, and that gives me 36.9 rounded, 36.9 degrees. So I'm going to change that theta to 36.9, and once again I can just do 90 minus 36.9 in order to get the other angle. So that's going to be 53.1. 53.1. All right, so that's how to use inverse trigonometry in order to find the acute angles of a right triangle.